Hi students, in today's section we discussed about thermal properties of matter. Okay, so in this chapter we may learn about the behavior of the matter with respect to the temperature variations. Okay, so first of all we would like to know about what is a matter. Matter is nothing but anything that has mass and occupies some region or some space. What is a matter? Anything that has mass and occupies some space. Okay, for suppose it's a pen, we know, and this pen has mass and occupies some space now. Watch has mass and occupies some space. Even me has some mass and occupies some space now. So which one occupies some space and has mass? That is related to the matter. Okay, observe your surroundings. Everything has mass and occupies the space. That's why around you everything is called as a matter. Okay, now how the properties of this matter are varies with temperature, we would like to learn in this chapter. Okay, just we observe certain things. For example, the power cables are always loosely stretched between the two poles. Your power cables are always loosely stretched between the two poles. Okay, and also we observe there is some gap is left between the rails of the railway track. Why they left this gap and why they are loosely stretched? Those power cables are loosely stretched. We know during summer temperature is rises and during winter temperature is decreases. Due to rise in temperature, expansion is takes place, and while fall in temperature, contraction is takes place now. So how they behave depend on temperature is learned in this lesson. Understand? We are familiar with two words. One is temperature and another one is heat. Okay, what is temperature and what is heat? Okay, to understand this, take an ice cube and place in your hand. Then you feel it is cold. Why you feel it is cold? Because ice has certain temperature, body has certain temperature. Okay, we know temperature of body is more than the temperature of the ice. So heat is form of energy which is always flows from the higher temperature region to the lower temperature region. That's why heat flows from body to the ice. Understand? So that you feel ice is cold. Okay, so what is temperature? Temperature always measures degree of hotness or coldness of a body. Temperature measures degree of hotness or coldness of a body, and it is a physical quantity measures direction of heat. It is a physical quantity measures the direction of the heat. What is heat? Heat is a form of energy which always transfers from the higher temperature region to lower temperature region. Heat is a form of energy which transfers from higher temperature region to the lower temperature region, nothing but from hot body to the cold body. Okay, this is the major difference between the temperature and heat. Okay, it just says the degree of hotness or coldness of the body. If you touch any body, temperature says whether it is hot or cold, and heat says it is form of energy that always transfers from the higher temperature region to the lower temperature region. That means if you touch a cold body, you feel it is a cold because heat will be transferred from your body to that cold body. Okay, the reason behind that one is heat. Is it clear? This chapter is classified into the number of portions. The first one is thermometry. Next one, expansion of solids, expansion of liquids, expansion of gases, and transformation of heat. So transfer of heat. So this chapter again classified into the certain portions. First one is thermometry, expansion of solids, liquids, gases, and transfer of heat. So in this section we are discuss about the thermometry first. Okay, so what is thermometry? It is a branch of heat which deals with the measurement of temperature. Branch of heat which deals with measurement of temperature. We know the temperature is measured with a thermometer now. So how the thermometer is calibrated? Okay, that is very important. Calibration. What is meant by calibration? Okay, so calibration means marking will be given with a scale by using a standard instrument. Calibration means marking will be given with a scale by using a standard instrument. For example, we are using meter scales now. Some people using glass scale and some people using the metal scales. Whatever may be, the readings on those scales are same or not. Means both are calibrated with the same standard instrument. Okay, our bikes has speedometers. On the speedometer some readings is there 0, 20, 40, 60, 80 like that. Okay, so depending on your speed and RPM of tire, RPM means rotations per minute of the tire, it always shows the instantaneous velocity or instantaneous speed of that motor vehicle. Okay, so it is also calibrated. Watch is also calibrated. The similarly, our scales are also calibrated. Thermometer is also calibrated. Okay, so in thermometer, we know the shape of the thermometer. So like this now. So in thermometer there are several readings is there. On that we can measure temperature of the body. By using this scale, we can measure the temperature of the body. So, while calibrating this thermometer, in earlier methods, they needed two reference points. One reference point is LFP and another reference point is UFP. What is LFP? LFP means lower fixed point. UFP means upper fixed point. Okay, lower fixed point. What is the mean? The meaning is by using this thermometer, what is the least possible temperature can be measured. Upper fixed point means upper fixed point, that indicates by using this thermometer what is the maximum temperature you can measure. Okay, in generally the melting point of ice is taken as lower fixed point and boiling point of water is taken as upper fixed point for thermometers. Okay, melting point of ice is taken as lower fixed point and boiling point of water is taken as upper fixed point. So in this thermometer, the least reading indicates lower fixed point and the highest reading indicates upper fixed point. Okay, and there is some gap between the UFP and LFP right now. So within this gap is divided into the number of equal parts. The gap is divided into the number of equal parts and each part corresponding to 1 degree. Each part corresponding to the 1 degree. Understand? Now we are discussing about different scales of thermometer. We have several scales to measure the temperature. On that, some are very familiar. We know about Celsius scale, and the next one is Fahrenheit scale, it denoted by the F, and for scientific purpose we are using always Kelvin scale. We have Raymer scale denoted by R, and in scientific purpose again we are using Rankine scale denoted by Ra. Okay, the temperature of atmosphere worldwide we are using the Celsius scale except United States. United States, the temperature of atmosphere and human body is always measured with help of Fahrenheit only. In India, in other countries across worldwide, we are generally using the Celsius scale. Understand? So, what are lower fixed points and upper fixed point for this different types of scales? The first one is Celsius scale. For Celsius scale, lower fixed point is 0 degree Celsius and upper fixed point is 100 degree Celsius. We know ice is melted 0 degree Celsius and the boiling point of water is also we know at 100 degree Celsius. Understand now? So the lower fixed point in Celsius scale is 0 degree and upper fixed point is 100 degree. Similarly, for Fahrenheit, it is 32 degree Fahrenheit and upper fixed point is 212 degree Fahrenheit. Kelvin scale, for scientific purpose generally we are using this one, 273.15 Kelvin and 373.15 Kelvin. Understand? Raymer 0-degree Raman and 80-degree Raman. And Rankine, the lower fixed point value is 492 Rankine and upper fixed point value is 672 degree Rankine. Okay, and now within the scale, how many number of divisions are there? To find the number of divisions, we said a simple formula UFP minus LFP. Okay, the difference between the upper fixed point and lower fixed point is divided into the number of divisions on that particular thermometer. Okay, so here it is 100 and it's 0 now. So 100 minus 0, we have 100 divisions in the Celsius scale. Similarly, 212 minus 32. 180 divisions is there in Fahrenheit scale. 373.15 minus 273.15. 100 divisions. 80 divisions. And again, 180 divisions is there. Okay. So, to measure the temperature of body, we have different types of scales. Understand? One is Celsius, lower fixed point is 0, upper fixed point is 100 and number of divisions are 100. Fahrenheit, 32 degree Fahrenheit, 212 degree Fahrenheit, divisions are 180. And Kelvin scale, 273.15, 373.15 and number of divisions are 100. Raman, 0 degree, 80 degree of Raman, number of divisions are 80. And Rankine, 492 and 672, number of divisions are 180. Okay, now we would like to give the relation between the different scales. So, conversion of temperature from one scale to the another scale. Okay, it is important because if suppose a person from United States, they want to come to the India. In United States, we said the temperature measured in Fahrenheit scale, but in India, we are using the Celsius scale now. So, he must be known the conversion, then only he feels easy. So, let us see what is the relation between different scales. Okay, there is a standard formula is there for giving the relation. That standard formula is x minus LFP by UFP minus LFP is always constant for all types of scales. Okay, whether it is Celsius or Fahrenheit or Kelvin or Rankine, whatever may be, this formula is always suitable. Here we know LFP, lower fixed point, and UFP, upper fixed point. But here what is X? X indicates the reading on scale. Okay. Please keep in mind, the temperature of body is always remains the same. But we are using different types of scales to measure the temperature of the body. Okay, I think just observe, in Celsius scale there are 100 divisions is there, but in case of Fahrenheit there is 180 divisions. So no doubt at all, the temperature of body remains the same, but those two scales shows different readings. Understand? So you must be required conversion of temperature from one scale to the another scale. Let us see. I would like to know about the relation between Celsius and Fahrenheit scales. So, the temperature of body measured with Celsius scale is denoted by the C. So, instead of X, I am using a symbol C in Celsius scale. So C minus lower fixed point value 0, upper fixed point value 100 minus 0. And in Fahrenheit scale, the reading on the scale is denoted by the F. Lower fixed point for Fahrenheit scale 32 na, by 212 minus 32. Okay, because this is constant for all types of scale, means what is the reading you observed in Celsius scale, it is same for Fahrenheit scale now. Understand? That implies C by 100 is equal to F minus 32 by 180. So 0 0 cancel. We can write C by 5 is equal to F minus 32 by 9. So by using this relation, we can get the conversion. For suppose the temperature of human body. The temperature of human body, normal temperature of human body is 37 degrees Celsius now. So what is the temperature in Fahrenheit scale? So instead of C, if you substitute the 37 here, then you got the value of temperature in Fahrenheit scale. Are you understand? So this is the relation between the Celsius and Fahrenheit scales. We know different scales now and this formula. So I would like to give one general expression which is useful for you for doing any numerical. Okay, let us see the general form. In Celsius scale, let the reading on the scale is C, then C by number of divisions in the Celsius scale. We know the number of divisions in Celsius scale are 100. Okay, LF value we know. C minus 0 nothing but indicates C only now. Now, in Fahrenheit scale, reading on the scale is denoted by F, and we know the lower fixed point is 32, and the number of divisions is nothing but UF minus LFP now. That is equal to the 180. In Kelvin scale, reading on the scale is K, and lower fixed point is 273.15 by 100. In Ramer scale, R by 80. In Rankin scale, RA minus 492 by 180. Okay, if they said any new scale, don't feel, just write this formula as X minus LFP by UFP minus LFP. Okay, if you remember this general formula, then numericals are becomes easy to us. See, I want the relation between the Celsius scale and Kelvin scale. Celsius scale, Kelvin scale. So take only these two. Then what we have? 100 cancel now. We have one relation. C is equal to K minus 273.15. Understand? Now I want the relation between the Fahrenheit scale and Kelvin scale. Fahrenheit scale, Kelvin scale. Just equate these two. You got relation now? I want the relation between the Celsius scale and Raman scale. So equate these two. You can get the relation between those two. Understand? Sometimes they took some faulty thermometers. Faulty means in thermometers there is some mistake is there. Okay, fault. Okay, so if they said the lower fixed point and upper fixed points for the fault thermometer, just substitute those values in X minus LFB by UF minus LFB formula. Then in what temperature they ask, just equate them. For suppose faulty thermometer reading is given in degrees Celsius and asking what is the accurate reading, then C by 100 is equate with the x minus L of p by UFP minus L of p. Are you understand? So please remember this formula, then it is very easy to solve the numericals. Understand? In the next section, we are discussing about some numericals related to this relation and the graphs drawn between the different scales. Understand? Thank you.